All right. So, Mason resisting. Okay, here's what I want to do. I'd like to remember we have a couple things. We have tests coming up Monday. Okay, here's some resources that you can use this weekend. Obviously, the YouTube stuff, huge. Use those things. People that used those last year, I'm going to start keeping stats because people that used them had to have an average of like 15% higher grade point average. I mean, it really makes a huge difference. Use the YouTubes. I've got the all the PowerPoints up. The review, obviously, you got to have done by Sunday night. We're going to go through a couple review problems today. I will also put up, right after school, I will put up a practice test for you to use if you want to. It doesn't count for anything. It's worth no credit, but it's going to be authentic practice for the test. It's the same kinds of questions. The penalties apply just like the test. It can't hurt you or help your grade. Indirectly, it can help you a lot, though, because it gives you some good practice. Make sense? What's that? It'll be available by 4 o'clock. Okay, so it'll be available this weekend. Yes, ma'am.
Are we still allowed to use our notes on the test, or?
No, I'm calling an audible on that. I don't really want to. I want you, and you'll see why here in a second. I want you to know this stuff for one thing. Okay, now I picked out 5 problems. There are 5 problems I want to just take a quick look at. I'm not going to do anything on this other than tell you how you could easily compare yourself. This is one of those topics, knowing the properties of addition and multiplication in math. It's one of those things that where I'm going to give you this opportunity to practice being good students before you head to college. This is one of those things where there's really not a lot of process stuff here. This is just memorization. Memorization is low-level learning. I shy away from it as much as I can, but sometimes there are a few things we just gotta know. In math too, there are a few, you gotta know the quadratic formula. You gotta know, there's a few things you just gotta remember. And these are some things that we're gonna come back to. Now, how can you remember all those different properties? There's only 11 of them. And here's a great way to do it. I'm gonna show you, this is the answer.
Okay.
This is the answer. Here's how you do it. Well,
Is it the magic koala in the corner?
The magic koala will get the job done for you. Yep.
He really is so hard at
Okay, here's what you do. Here's what you do. I'm going to share with you guys a secret weapon that, seriously, this is huge. This is huge. Now, here it is. This is one of the all-time keys to learning facts, lists of facts, which you're going to have to do forever in school. And I can't believe that you've probably never heard of this before because it's foolproof, absolutely foolproof. These little cards invented by Frederick Index. These cards are just absolutely unparalleled as a means of memorizing things. And here's how you do it. Here's what you do. It's very simple. One side of these cards, you put the question. On the other side, you put the answer. So, for example, on one side, you would write the commutative property of addition. Okay? Commutative property of addition. On the other side, you would write A plus B equals B plus A. And you do that for each of those separate facts on this table. Okay? And when you're done, you collect them up in a pile and you put a rubber band around them. And they're collected in one place. And maybe at the very top, you even write one card that's a title card that says properties of multiplication and addition. And then here's what you do with them. And then no. It's not an osmosis. You don't put them under your pillow. Oh, you can try it. But no guarantees with that.
I want to do it.
I don't think there's any kind of osmotic learning process happening here. But what you do, either you or your little brother or sister, your mom, dad, your friend, or whatever, or just by yourself, you can go through these things and you can do it both ways. You can read the title and have to reproduce the formula, or you can even start off going backwards. Start off reading off A plus B equals B plus A and try to remember what's the name of that property. And then gradually you work so you go the other direction. And then this is the great thing about it. It's a self-weeding process here. Wouldn't it be nice if your garden was self-weeding like this? You can just, as you get to know the facts, the cards that you keep getting right, you just set those down. and you only keep the ones in your hand that are the ones you're having troubles with, and so you get more trouble, or you get more practice on the facts that you're not remembering very well. It's great. And then when you're done, what do? Do you junk them? No, you don't. You collect them back up, you put the rubber band back around them, and you put them in a Ziploc with all the other packets of index cards you're going to create this year, and you got them for later then. You're studying for the final, or whatever. Or, you know, maybe you'll need them next year, but you just leave them. They're not that big. Put them in a Ziploc, throw them in your closet somewhere, and you got them. Right? Eventually, you're going to have a closet full of index cards.
History. They can take up a lot of room.
Well, I will not produce that abundant a stack of index cards for you. There'll be very few instances where you'll have to use those things, but this is one where it really helps. Okay? Make sense? I promise you. Try it. If I'm wrong, tell me, but no one's ever told me I'm wrong. They always work. They always work. Oh, the YouTube thing. Okay, now, the YouTube thing. How do we get to YouTube? Here's how we get to YouTube.
Go to internet.
Go to internet. You actually could. I think you could just probably.
Just type in internet.
I bet you could just do a search on Mr. Oya, and I'm sure it would probably come up. But here's all you have to do.
Just put Eric Oya.
Probably would work. Come on. Okay, here's what you do. If you go to the, look please. Okay, if you go, come on. If you go to the Algebra 2 page, there's two places where you can find this. Let me make this a student view so it looks just normal to you guys, because this is really good. I spend a lot of time putting these together, but I think they're worth it. If you go to Course Resources, that's one place you can find it, and you go down to Instructional Videos. It's going to take you straight to BuckTube Math. How about that? Okay, that's right. I renamed it. You like that?
That's awesome.
Okay, and you can go to Playlists, and you want the one that says Algebra 2 Unit 1 right there. So click on that, and up pops the playlist, and there they are. Okay? They're in reverse chronological order.
Can you play one?
Yeah, sure. This is
Wait, what's that picture on the top?
that's Stanford.
Oh, it is.
Stanford, yeah.
Wow, it's fancy.
Isn't it nice?
Is that in California?
Kind of
What's-
looks like
yeah.
Greece.
Yeah.
Okay.
Yes. Okay, so if I play this, watch. Shh. Hey, listen. This is a small class. We shouldn't have these issues. Come on now. Okay, so if I play this, it's just gonna pop up like I hate listening to my own voice. So I'm only gonna play this for like 5 seconds. It's gonna just I can't stand it anymore. But it's popping up. No, I think that's generally true. Come on. There we go.
A lot of people.
Okay, and so this is gonna pop up like any YouTube thing. You can just kind of do this little number, and you can drag through and say, "Oh, that's the part I need to see right there." So you go to that part, watch it. All you hear is me, and then you just see the whiteboard, and that's it. Okay, I gotta turn that off. That's just. Do I really sound like that?
I can't hear it.
Turn it up. Don't turn it off.
Okay.
Can you turn the volume
So,
up?
like, one of the students.
Yeah, my volume's just. Whoops. How do I get escape? Right. Where's? I just have this really low. Oh, do I really sound like that?
No,
That's
not
what
like
you sound like.
No.
Yeah, your voice is really.
I heard it. Like church?
Oh, I gotta turn that off. I can't stand it. Ah. Okay. Anyway, there you go. That's how you do it. Okay, they're all right there. They're all available. I will try to go in when I get a spare second. I'll try to go in and rather than just have dates on those, I'll try to like label them by what they really are. But you can sort of find it. Okay. Let's push on here. So you know how to use these flashcards. Frederick Index. You are going to be thankful to old Frederick.
Try to, like, pop it in
Okay,
there.
so what about these? Here's another one that came up. I just looked through. Moodle allows me to look down at the bottom of assignments and just see which problems people are having trouble with, and this was one of them. Understand why. Not that it's hard, but we just didn't spend any time at all, or very little, if any. What is this stuff here? Match the equation with the number of solutions. Quick reminder from years past, and we'll do a lot more stuff with this year. All this is saying is, if I solve these equations, one of three things is going to happen. Let's take an example of each. Let's take the bottom one, for example. If I solve the equation in the bottom one, don't I just subtract 2x from both sides? Agreed?
Yeah.
So I get 4x on the left. If I subtract 3, I get 6. If I divide by 4, I just get some answer. I get x equals 6 over 4, which reduces to 3/2. But I don't care. I could see right away at this step right here that I was going to get a solution, wasn't I? I don't care what it is. I just want to know, am I going to get 1 or not? Yeah, I got 1. So one solution is the number of solutions for that equation, right? Okay, let's look at the one on the top. If I solve the one on the top, if I subtract 6x from both sides, the x's go away completely, and I get the equation 24 equals negative 24. Okay, how often is that true?
Not very often.
In fact, it's true never, so there are no solutions, right? See the connection? Okay, what about this guy right here? If I solve that one, when I subtract 2x, I get the equation 8 equals 8. How often is that true? Always. It's infinitely true. It's always true, and so there are infinitely many solutions. Make sense? That's it. That's what you're doing there.
Let's do it.
Okay?
Perfect.
Okay, what about, now the last, I want to look at a couple more examples and we'll get out of here. These are the ones, if you can do these, you can do them all. If I have something like this, I want to know what to do, and I'm interested in the process, because people are ignoring the process here. They're trying to take shortcuts to the answer, and that's not what we want to do. If I have an equation, an absolute value equation, like absolute value of 3x plus 1 equals 11, what do I do to solve that absolute value equation? Or, good, but using the word or, you're right. Or 3x plus 1 equals negative 11. You don't do this. You don't try to do algebra with those absolute value bars there. The first thing you always do is get rid of the absolute value bars. We don't want them there. So we're going to rewrite this as two separate equations. 3x plus 1 equals positive 11, or 3x plus 1 equals negative 11. Waste a little paper if you need to. It's fine. Doing, especially on a test, you want to give yourself a chance to do the organized work and you won't make mistakes. Then just solve them both to get your two answers. I won't even bother with it. You can do that, right? But write the two equations and solve them separately. Okay, what do I do in this case? Let's look at just a couple of these, right? If I've got, this is a step harder probably. If I've got an absolute value inequality, do I try to do the work with the absolute values there? No. I want to get rid of them. I'm going to make my trade. These problems, when you saw these, you probably thought these were a little weird looking, but I purposely made these problems this way so it would force you to think about it in the right way. The first thing you want to do here is don't even bother with the numbers. The first thing you want to do is establish what kind of a trade am I making? When I get rid of the absolute value bars there, which kind of compound inequality do I get? Do I get an and? Whoops. Do I get an and or an or? Which one's it going to be and why? It's going to be an and how come? What tells you and instead of or in this case? Okay, I'm seeing it. I'm seeing this kind of thing, right? It's this absolute value sign, because it's the direction of the absolute value sign tells you it's and. If it's an absolute value expression is less than, that always means and. Now, which one of those two and statements applies here?
2.
2, because there's no equal sign with the inequality, right? So we know it's a 2, right?
Yeah.
And then all we do is everything inside the absolute value bars goes in the middle of the and statement, right? So that stuff just goes there. What goes on the outsides? -7, 7, and I just solve it, right? But let's do this one, because there's still another trick here that we got to be careful of. What do I do to solve this for x? What are the two steps in order? Okay, I'm going to subtract 2 from everything. Cancels there. I get a -9. 5 and a negative 5x. Has the inequality sign changed yet? No, hasn't. Now what?
Divide.
Good, divide by negative 5. Okay, sign rules. Negative divided by negative is positive. So I just get on this side, I just get my positive 9/5. Over here, negative over negative, or positive over negative is negative, right? So I get my negative 1. In the middle, I get my x, but what do I have to do? I divided by a negative, and so, right, because I divided by a negative, I have to flip those signs around. Okay, and then the last step, remember we have that last little trick. What do we have to do with that? Good, we gotta do the glass trick, right? Okay, there's another way to think about the glass trick. If using the glass trick works for you, that's great, keep it. If it doesn't, if you're having trouble with that idea, here's what you can do. If the inequality signs are backwards in an and expression, you can read it from right to left, but write it from left to right. So as I read it up here, I'm going to start off with a negative 1 is less than x is less than 9/5. At least that's how I read it. I'd say it x is greater than negative 1 and less than 9/5, right? That make sense? So as we read it this way, we're just writing it this way and it flips it around. Okay? Good? Oh, and so then what's A and what's B? If we look back, last deal, if we look back up here at number 2, A and B are specific. They're not just random. A is the number that x is greater than, right? B is the number that x is less than. So this has to be the A, and that has to be the B in my answer. Okay? Okay, last example. We're done for the week. This guy. Okay? Once again, we got an absolute value inequality, so the first thing we want to do is before we even look at the numbers at all, we want to decide what kind of a trade are we making. So what's it going to be this time? Say it again. Is it an and? If I've got a greater than sign there. And this would be another great place for flashcards, wouldn't it? Right? I think it would be. One side of the flashcard, you put something like this. Absolute value of AX plus B, just like in our PowerPoint presentation, is greater than C. On the other side of the flashcard, you put AX plus B is greater than C, or AX plus B is less than negative C, right? Then you got it. Okay, there's another great flashcard, another stack of flashcards. That closet's getting full. Already it's getting full. Okay.
Yeah.
So we're going to make a trade for which one then? Well, I guess I just gave it away. It's an or, right? It's an or. Which one applies here of the two ors? 4, because I don't have equal signs in there. Right? And so whatever's inside the absolute value bars is going to be greater than the positive and less than the negative. Now, the easy way to remember that is when you write the first statement, all you're doing with your eraser is just erasing the absolute value bars to make the first one. Right? So you get negative 6x plus 4 is greater than 2. I just got rid of the absolute value bars. Or negative 6x plus 4 is less than the negative number. Right? Solve them both. What are the two steps I go through in both cases? First, I subtract 4, so I'm going to get negative 6x is greater than negative 2, or negative 6x is less than negative 6. Now what? Divide by negative 6, so what do? Flip the sign. I get x is less than, negative over negative is positive, right? So less than 1/3, or x is, flip it, greater than 1. Because I'm trying to get rid of, the snake. I want to get the x by itself. Right, so I got to cancel those negative 6's. Does that make sense? See, in this original statement up here, I've got this inequality I'm solving separately from that one. This one or that one. To get that, if I can point to a single x, I can isolate it. Well, there's a single x in that inequality, so to get that x by itself, I subtract 4 away, and then divide by -6.
Yeah, but that name.
Because I skipped this one. I subtracted 4 from both sides. -2 minus 4 is -6. There you go. Yeah, I got you. Okay? Make sense? Okay? And so which is A and which is B? Well, A has to be the value that x is less than, so A is 1/3. B has to be the value that x is greater than, so B would have to be 1. Right?
Right.
We good?
Okay.
Yep.
All right. 2 up. 2 up on that.